Hi guys, I have here another question, very interesting, and this is a trig question from an A-level sample. Now the question is given that y equals a sine x plus b cos x with the maximum value being y equals 4, and the curve passes through the points coordinate x pi on 3 to root 3. So we have to find the value of a and b, the exact value of a and b. Now since the maximum value have been given, the max has been given, so what you have to do first is to find an expression for the max value. Okay, we find an expression, or we find an equation in terms of the maximum value. So we are looking at a differential approach. So we first differentiate the equation here. So this will be, so first differentiate. So you have dy on the x, which will be equals to, differentiate this, you get a cos x, then minus differential of cos x will be minus sine x, so b sine x. Now since it's the maximum value, which is the turning point, we equate this to 0 and we find an expression, okay, for x. We find an expression for x. So what we do is to drop this differential ratio and you solve this. Okay, so we find a common trig approach, a common trig ratio to solve this. So we divide through by cos x. So this will be, this implies that dividing this by cos x, you get a minus this becomes sine x divided by cos x will give us tan x. So b tan x equals 0. Making tan x the subject, you have tan x equals a on b. Still making x the subject, you have x equals tan inverse of a on b, and this is our first equation. We now use the value itself and insert the value into the equation given, so that you get an expression as well. And this time around, after you get the expression, you insert the x expression in it. So we have, now this implies that 4 will be equals to a sine. Now instead of writing x, we write this as this expression here. So tan inverse of a on b plus b, then cos of tan inverse of a on b. Okay, now we know that tan inverse of a, or arctan of this will give us x, and sine of an x should give us the ratio of two sides, which is the ratio of the opposite on the hypotenuse, and cos will give us the ratio of the adjacent on the hypotenuse. So you can make a sketch. I will make a sketch for easy understanding. So this is the x, there will be opposite, so a b. Hypotenuse is what you're looking for. When we're looking for the hypotenuse, we use the Pythagoras theorem approach. So you have the hypotenuse will be equal to the square root of a square plus b square. So this means that sine of x will be equal to opposite on adjacent, opposite on hypotenuse, sorry. Cos of x will also be equals to adjacent on hypotenuse. So we take note of that. So we'll be having this implies that 4 will be equals to 4 will be equals to a, then the sine of all this, so the sine of x will give us opposite, and the opposite is a on the hypotenuse, which is this. So a square plus b square. So you have that. Then plus b. Okay, and cos of the x will give us adjacent, which is b on square root of a square plus b square. Of course, you could have moved straight from sine x to this. You shouldn't have done this. You could have decided not to do this, okay, and not to do this. By the way, I'll just hoping it will be clearer to insert all this. All right, so we expand this, okay. So we simplify a times a and everything. Yeah, so going up. Okay, so we have 4 will be equals to, right, 4 will be equals to a square on square root of a square plus b square plus b square on square root of a square plus b square. All right, so we can simplify that as 4. So we have 4 equals a square plus b square on square root of a square plus b square. Okay, I want to remove the square root, so we square root both sides. Squaring both sides, you have 16 equals, so that makes it simpler to solve. A square plus b square all squared on a square plus b square. Now this looks similar to this, so you can even put it in bracket. So that takes, you apply the law of indices, so the power reduces. So you have 16 will be equals to a square plus b square. Okay, so here you have your equation 1, your first equation. We now generate another equation in terms of a and b, but this time around we'll use the points. So we've used this, we use the maximum, okay, we now use the coordinate given to us. So using the coordinate will be, so using the coordinate, we are having just insertion will be 2 root 3, that will be equals to a sine pi on 3 plus b cos pi on 3 as well. So you have, this implies that 2 root 3 will be equals to a sine of pi on 3 will be equals to the square root of 3 on 2 plus b pi on 3 will be equals to cos pi on 3 will be equals to 1 on 2. Okay, so we can simplify this by multiplying through by the LCM. So we have 2 times this, you get 4 root 3 equals, this is a root 3, and this will be plus b, making b the subject so that it should be easier to substitute in the above here. So we have 4 root 3 minus a root 3 equals b. We factor out root 3, so you have 4 minus a, or multiply by root 3 equals b, and this will be equation 2. You put this into the above here. So we having, this implies that a square plus, instead of b we put 4 minus a, the b squared, so squared, root of 3 will also be squared. Okay, all equals to 16. Then we expand this, so we have, this implies that a square plus, opening the brackets, binomial expansion here, so 16 minus, okay, then plus a square minus 8a, all multiplied by 3 equals 16. Okay, so we go up. Okay, so continue, a square plus 16 times 3, 16 times 3 will be 48. Okay, 16 times, so we have a square, so that will be 3a square, and negative 8 times 8, that will be 24, negative 24a equals 16. So we have a quadratic expression here, so we can form a zero equation. So we have 4a square minus 24a, okay, then plus 32 equals 0. We can further factorize this, so you have a square minus 6a plus 8 equals 0. So to factorize, just bring your two brackets, the a is squared, so a here, a here. The coefficient here is 1. 1 times 8 is 8. So you look for two pair factors. Okay, you look for pair factors that when you add, you get 6, and that is 2 and 4. Pair factor of 8 that when you add, you get 6. So that is 2 and 4. So 2 and 4. It's minus, so it's minus 2, so you have 0. So a equals 2, a1 equals 2, and a sub 2 equals 4. We use this now to find for the b. do not forget the equation here. Okay, so that will give us a b1 will be equals to 4 minus a is 2 times root 3, so which will be b1 equals 2 root 3. We do the same thing for b2, so b2 will be equals to 4 minus 4 root 3, and that will be equals to 0. Alright, so we have a1 equals 2 4, or when b1 equals 2 root 3, and we have a2 equals 4, whilst b2 equals 0. But this does not satisfy the equation because the curve is not passing through the origin here, and when a equals 4 and b equals 0, that means the curve needs to pass through the origin here. That's because b cos x will be eliminated, it becomes 0, and this will be left. So our exact values will be this, will be a sub 1 equals 2, b sub 1 equals 2 root 3, and that will be our answer, and this will be discarded. Do not forget to like, share, and comment. This is Math with Delmi. Thank you.